Hi everyone. In this lesson, we're going to go through the conditional statements on how to approach a logical argument. Now with this, I'm going to show you how you can actually use logic to talk about analysis and hypotheses and conclusions. So by the end of this lesson, you'll be able to define a hypothesis and conclusion, as well as determine the conditional value truth statements. So in your notes, you should see that there is a diagram that has sort of a chart, and I want you to copy down this part in the meaning, but I don't want you to do it all. I'm just going to underline what I need you to copy. If P, then Q. P is hypothesis, Q is conclusion. So in all of our statements that we're going to talk about, we have these two things, a hypothesis and a conclusion. So a really common example of this is the statement, if it is raining, then I will use an umbrella. So there's a condition. If it is raining, what we can then say logically is that I will use an umbrella. So if I look outside right now and let's say it's sunny, then I can't really make a statement because all I know is that if it is raining, then I will use an umbrella. So the fact that it's sunny doesn't validate our hypothesis, so we can't make a conclusion. But if we look outside and it happens to be raining, then we know for a fact that I will be using an umbrella. So that's how this is going to work, where we look at the condition. If the condition is fulfilled, then the conclusion has to be valid. If the condition is not fulfilled, we really can't make a statement. Now for the symbol part of this sentence, or the box, I just want you to write this. So this arrow is actually saying the statement, if P, then Q. And finally, for the diagram, I just want you to kind of realize that your hypothesis is sort of nestled within the conclusion. So the idea, and I'm going to take that sentence again, if it rains, then I use an umbrella. And I want you to think about the possibilities here. So the condition, if it rains, if it's fulfilled, I'm in this, part of the diagram, which means I'm in the overall conclusion, I will use an umbrella. But is there a scenario in which I would use an umbrella and it may not be raining? So from that, we can kind of think about, in terms of this hypothesis, this is when it rains, this is where I fall, but I may have another scenario in which I use an umbrella. Maybe I'm on the beach, maybe I don't like the sun, and I use a solar sort of umbrella, parasol I think they're called, okay? So the idea is that when this first condition is satisfied, we know what has to happen next. But just because the conclusion happens doesn't necessarily mean that the hypothesis is true. So it kind of works in one direction, but not always in the other direction. So let's actually identify how we can find hypothesis conclusion. The good part is they're really easy to find. Hypothesis, you're looking for if. Conclusion, you're generally looking for then. It doesn't mean that's always going to be the case. It just means it's the easiest way to find it. So for example, if it is raining, that's my hypothesis, it is raining, then I will use an umbrella. So that's my conclusion. Now for our next one here, if everyone gets an A on the test, then we will have a pizza party. So we will not have a pizza party until everybody gets an A on the test. So that's, again, just because everybody gets an A on the test, that's going to imply we have a pizza party. Now, hypothetically, we could have a pizza party. It doesn't necessarily mean everybody got an A on the test, but what we know for a fact is if everybody gets an A on the test, then as a result, we will have a pizza party. And then the last one here, the dog will bark if it sees a cat. Now, this is a little bit out of order, but there's a condition is that the dog needs to see the cat first. So notice how the if does not come at the beginning of the sentence here. And what's going to happen as a result of the dog seeing the cat? Well, the dog will bark. Notice how this is missing a than. So that's what I was trying to say. Sometimes these pieces are missing. Whoops. Now, to be very clear, it wouldn't make sense for me to put than in this sentence. If I said, then the dog will bark if it sees a cat, it doesn't make any sense. So grammatically, putting then at the beginning of the sentence doesn't make sense, but you can read it as it is, and it kind of makes sense without the than. So here's an example of, let's take a sentence and let's write a conditional. An obtuse triangle has one obtuse angle. So I try to look for a verb. That tends to be where I split, because your verb in a sentence generally gives you an effect of cause and response. So we could say, if a triangle is obtuse. Now there's a lot of ways to say this. You could say, if the triangle is an obtuse triangle, if the shape is an obtuse triangle, if it is an obtuse triangle. You don't need to overly complicate the sentence. We just need to say, if this is the case, if a triangle is obtuse, then as a result, this has to happen. It has one obtuse angle. That's it. So maybe you want to try to pause this in a couple seconds and give these two a shot and see how you do. So I wrote the first one out here, and then I'll do the second one with you. If the animal is a fish, then it lives in water, right? So fish live in water. We don't want to make this super complicated. If you put something like, if a fish lives in water, then it lives in water, that's just really repetitive. So you just want to say, okay, fish do what? They live in water. So the condition is that it has to be a fish, and as a result, it lives in water. And we can think about this, right? Can we think of an animal that lives in water that's not a fish? Right? So, for example, you might think turtle. There's debate about whether shark or dolphin actually count. Then there's creatures that live in water that definitely aren't fish. Sea urchins, sea cucumbers. Those are all things. Okay, so just because it lives in water doesn't guarantee it has to be a fish. What we can say is, if it is a fish, then it's going to live in water, because that's the condition of being a fish. All right, last one. Two angles are complementary, must be acute. So again, there's no real good verbs here, so we want to think about it this way. We have two angles that do what? They are complementary, and as a result, they must be acute. So technically, must is my verb in this sentence here. It doesn't feel like it's a very good verb in this sentence, but we can say, if angles are complementary. So you notice how I'm not taking the entire sentence. I mean, and you could basically copy this in two pieces, but then they must be acute. So with that, there are three other statements. So if you flip over to the back page of your notes, we're going to have what we call the converse statement, the inverse statement, and the contrapositive. So in your notes, there's three boxes next to those words. I'm going to ask you to write down what I'm highlighting here. So next to converse, I want you to write reciprocal of conditional. In the inverse box, I want you to put negation of conditional. And in contrapositive, I want you to put negation and reciprocal, okay? So in those blank boxes above, reciprocal, negation, negate, and reciprocal. So the idea is all of our statements can be moved around, and they all have different meanings to their purpose. So we have symbols to go along with them. So I'm going to highlight the symbols in blue. I'm going to write it down. So symbols, in your symbols box, I want you to put what's highlighted in blue. That's this, P arrow Q. Under inverse, the little squiggly, P arrow squiggly Q. And finally, contrapositive, squiggly Q arrow squiggly P. And then the last one, I want statement. I'm going to put that in green. And what I write in green is what I want you to put in the statement box. So this says, if Q, then P. This one, because of the little squiggly means not. So this is going to say, if not P, then not Q. And again, this would be if not Q, then not P. Okay, so again, everything in red should just go in the blank box at the top next to that word, converse, inverse, contrapositive. In the symbol box should be what's highlighted in blue, and what's in the statement box is what I wrote in green. Okay, so all of these statements have some sort of truth to them, and we'll talk about it in my next example. So let's take the first example below, and the statement is, if I order an Americano, then I will get a coffee. So for those that are unaware, an Americano is a type of coffee, and I'm going to just talk about it that way. That way we're all on the same page here. Okay, maybe you do know what it is, maybe you don't, and that's fine. But Americano is a drink where part of it is coffee and the other part is hot water. So if you're familiar with different types of coffee drinks, this is similar to a latte without any milk. But if you order an Americano, there is coffee in it. So this is definitely a coffee-based drink. So let's think about this. So if I order an Americano, that's my hypothesis. If I order Americano, then that's my conclusion. I will get a coffee. So my converse statement, we're going to do Q implies P. So instead of saying if I order Americano, then I will get coffee, I'm going to switch my P and my Q around. So basically, what's here and here are going to get flipped. So for the converse, I'm going to say if I get coffee, then I will get an Americano. So that's it. That's how you do the converse. You just literally just flip the sentence. Let's see. Oh, there we go. Okay. Now, for the inverse is the negation of the original. So I basically just say, like, this is not going to happen on both sides. So I don't change anything from the original sentence. We're still working from the original sentence. So I'm going to say, if I don't, get an Americano, then I won't get coffee. And that's it. So notice how I didn't really change the sentence all that much. I just put nots in both sides. If I don't get an Americano, then I won't get a coffee. That's it. And in our last sentence, the contrapositive. So this is going to do both of these things. I'm going to switch the order, and I'm going to negate both. So what you might want to consider is just rewriting your converse statement with your negations already sort of put in there. So I might actually look at the converse. So instead of saying if I get a coffee, I'm going to say if I don't get coffee, then, again, I'm just going to say the same sentence, but just putting a not in there. I will not get an Americano. And what I want you to think about is if I read all these sentences, we're going to determine which ones have to be true and which ones have to be false. So picture yourself in a Starbucks, and the first sentence is, if I get a coffee, then it has to be an Americano. Is it possible that I order a coffee drink that's not an Americano from Starbucks? And hopefully you know enough about coffee, you know that there's plenty of other options. So this is actually a false statement, right? I can get a coffee that's not an Americano. I could just get a plain coffee. I don't need anything else in it. I could just get pure coffee. That's not an Americano. So that's a false statement. Now my inverse, if I don't get an Americano, then I won't get a coffee. So again, picture yourself in line at Starbucks. You're not allowed to order an Americano, but can you order anything else? Yes. Can I still order a coffee? Yes, I can still get a plain coffee then, because my only restriction here is I can't get an Americano. Now, here's where it gets interesting. If you don't get a coffee, so think about it being in that line, and now I'm telling you, you're not allowed to order anything that's on the coffee menu. Can you possibly get an Americano? And the answer is no, this is not possible. Because if I don't get a coffee, I can't order Americano. So even though that we are restricted from getting a coffee, this is a true sentence, because If I don't get a coffee, I can't get an Americano. The only way for me to get an Americano is if I get the coffee. So what you should have on your note sheet now is 2 more examples that I want you to try, and then we'll come back and talk about if you got those correct. So I think the first statement is about driving and being over 16 years old, and then the next sentence is about eating lunch in the cafeteria. So I'm going to come back with my answers for those, but try writing the converse, inverse, and contrapositive now. Okay, so these are the 2 examples that you should have. So if you drive a car, then you're at least 16 years old. The converse would be to flip the sentence. If you are at least 16, then you drive a car. Now, can we think about a scenario where this is false? If you are at least 16, then you drive a car. So at 16 years old, does everybody inherently have the ability to drive a car, assuming we're doing this legally in the state of Pennsylvania? No, right? You have to take a permit test first, and then you have to actually get your license test. So just because you are 16 doesn't mean you're allowed to have a permit or a license to drive a car. You can get one, but that doesn't mean you immediately have it. Now, if you don't drive a car, then you're not at least 16 years old. So I like to think of sort of my grandparents. At a certain point, they did not drive a car because they were not really capable of driving a car. So just because you are 16 doesn't mean you drive a car. There are cases where you are older than 16 and still can't drive a car. Finally, if you're not at least 16, then you do not drive a car. So if you're not at least 16, that means you are 15 and younger. So in this case, if you are 15 and younger, are you technically allowed to drive a car? No. So this is a true statement, because if you are 15 or younger, you cannot drive a car. That is correct. Now, our last sentence here, if we eat lunch in the cafeteria. So I rewrote that as a conditional. If we eat lunch, then we are in the cafeteria. So if I do the converse, if we are in the cafeteria, then we are in lunch. Just because we eat lunch in the cafeteria doesn't mean I can't be in the cafeteria and not be eating lunch. So that's another false statement. The inverse, if we are not eating lunch, then we are not in the cafeteria. Again, we could be in the cafeteria, but we don't have to be eating lunch. But if we are not in the cafeteria, so we're somewhere else in the school building, then we are not eating lunch. That has to be true, because basically we're only allowed to eat lunch in the cafeteria. So if I'm not in the cafeteria, I can't be eating lunch because it's the only place I'm allowed to do it. So I hope this makes sense what these statements are. Next, you should be starting a little activity in which you will walk around the room and collect facts and try to determine what happened in the school building. There's sort of a little mystery I need you to solve using the conditional statements. So for that little activity, what I need you to do, and this is my sort of hint, for that activity, I want you to walk around and write all the blue statements down. You might be able to use a piece of paper or a little piece of scratch paper. Okay, I'll leave some there. Write them down on scratch paper, and then determine which orange papers are true. So we're going to kind of do this as a clue-style game where you have to find who did what and where did it happen. So if you read all the statements correctly, you should be able to find one of the people, Mr. Orange, Dr. Plaid, Mrs. Yellow, did something, took a textbook, throw a pencil, stole a cookie, where in the cafeteria, library, or a classroom. So that's what you have to do, some detective work, and look at all the blue statements first, and then look at the orange statements to use the facts to determine if it's true or false, okay? So do me a favor, try that, see what combination you come up with, who did what where, and then let me know what you think. See you in the next class.